Hello everyone, I am Yehaasary studying BTECH Artificial Intelligence and Data Science in JANSONS Institute of Technology, Coimbatore. And here it's a video on physics case study. My topic is justify the importance of matter waves and its understanding to the present world. After the completion of video, you could able to understand what is mean by matter waves and importance of matter waves and about de Broglie hypothesis and the difference between matter waves and electromagnetic waves and what are the real life applications of matter waves and example of matter waves. Here, introduction on matter waves. In physics and chemistry, wave particle duality holds that light and matter exhibit properties of both waves and particle nature. As said here, for example, a beam of electron can be distracted just like a beam of light or a water wave. However, the wavelength is too small to have the practical impact on day-to-day lives. Next, historical context about magnetic waves. At the end of 19th century, the light is consist of waves of electromagnetic fields which propagated according to Maxwell's equation, while matter thought that matter consists of localized particles. In 19,000, this division was exposed to doubt. Then, investigating the theory of black body radiation, Planck proposed that light is emitted in discrete quanta of energy. And after the investigation in several ways, including its connection with the photoelectric effect, Albert Einstein proposed that light is also propagated and absorbed in quanta. Here he mentions it called as photons, and it has Planck-Einstein relation also. We can see this equation in detail. Einstein's postulate was confirmed experimentally by Robert Millikan and Arthur Compton over the next decades. Next, what is matter wave? The wave associated with the material particles like electron, proton, etc. are called matter waves. It's a concept of de Broglie. Since nature loves symmetry, in 1924, Louis de Broglie suggested that an electron or any other material particle must exhibit wave-like properties in addition to particle nature. It exhibits dual nature, he says. Next, example of matter waves, interferometer. Interferometer is a device that extracts information from interference. What is meant by interference? Interference is a phenomenon of superposition of two waves to form a resultant wave of greater or lower or the same amplitude is known as interference. They are widely used in science and industry for the measurement of microscopic displacements and refractive index changes and surface irregularities. Interferometer is a technique in which uses the interference of superimposed waves to extract information. It is an example of matter waves. Here we can see. Next, importance of matter waves. The importance of matter waves are not electromagnetic waves. Electromagnetic waves have a source, while matter waves are not emitted from any source connected to the matter around us. Electromagnetic waves has larger lambda and can travel in vacuum. Matter waves have small lambda and can't travel in vacuum. Matter waves are new kind of waves which is due to the motion of charged particles and electromagnetic waves are produced. The wave and particle aspects cannot appear together. Locating the exact position of a particle in a wave is uncertain. Does not necessarily have to be charged. Just like electrons, neutrons, when we move with V is not equal to 0, they are called matter waves. Thus, neutrons with no charge show that matter waves does not necessarily have to be charged. Lighter particles will have high wavelength. Particles moving with less velocity will have high wavelength. Here, lighter particle and particle moving with less velocity both have high wavelength in terms of matter waves. The velocity of matter waves is not constant, it is dependent on the velocity of a particle. Only particle in a motion, that is particle with V not equal to O, V is not equal to 0, behaves as a matter waves. The velocity of a matter shall be up to the maximum of velocity of light. It depends on the velocity of a particle also. Next, de Broglie hypothesis. Here, de Broglie introduced electromagnetic waves behaves like particle, and the particle like electrons behave like waves, is called matter waves. Here, de Broglie hypothesis plays an important role in matter waves. He derived an expression for the wavelength of matter waves on the analogy of radiation. According to Planck's radiation law, H is equal to h c by lambda. C denotes velocity of light and lambda is a wavelength. According to Einstein's mass energy relation, E is equal to mc square. From 1 and 2, lambda is equal to h by p, where p is the momentum of a photon. It can be proved that the matter waves travel faster than light. Before that, we saw this in importance of matter waves. The wave velocity is given by substituting for lambda. We get W is equal to c square by v. As the particle velocity v cannot exceed velocity of light c, omega is greater than velocity of light. It is one property of matter waves. The above relation is called de Broglie's matter equation. This equation is applicable to all atomic particles, and if E is kinetic energy of the particle, then its E is equal to half mv square, formula of kinetic energy. After that, E is equal to p square by 2m, p is equal to root of 2me. Hence, the de Broglie's wavelength lambda is equal to h by root of 2me. Here we can see about the difference between matter waves and electromagnetic waves. Matter waves is associated with moving particle, while the electromagnetic waves oscillating charged particles give rise to electromagnetic waves. Wavelength depends on the mass of the particle and its velocity. Lambda is equal to h by mu. Wavelength depends on the energy of photon. Lambda is equal to hc by E. Can travel with a velocity greater than the velocity of light, matter waves. But in electromagnetic waves, travel with velocity of a light. It travels similar to the light. C is equal to 3 into 10 to the power 8 m into s. Matter wave is not electromagnetic wave. Electric field and magnetic field oscillate perpendicular to each other. Here is a electromagnetic wave. Then real life application of matter waves. An electron microscope is an instrument that takes advantage of this situation. It plays a vital role in matter waves. Then using magnetic fields, they are directed at an object of interest. The electrons are focused to illuminate the object and then to form an image of that object. This system can be used to look closely at very small objects. The wavelength of the electrons are related to their kinetic energies only. In electron microscope, wavelengths as much as 1 lakh times smaller than those of visible light can be achieved. With such small wavelengths, electron microscope can reveal features that are small as 0.00001 meters, 1 nanometer it seems. Here we can see how much small microparticle we can see here. It's useful, matter waves is useful for electron microscope, so that we can able to see the images which are very small in a enlarged, and we can easily able to focus the image. Here is a diagram that shows the matter waves and the wave which has frequency and velocity, mass. It's all shown here. Thank you. Hope you understand this video.